Did you feel confused when you saw an unknown resistor and an unknown current in this circuit? Well, you're not alone. Many students actually fell into this trap in JEE Mains 2025. But here's the good news. If you watch this video till the end, within 3 minutes, you'll gain the confidence to solve this and similar questions. Welcome to the 6th video of our current electricity numerical series. Let's get started. The key to solving this problem lies in understanding the Wheatstone Bridge. So first, let's quickly revise the condition for a balanced Wheatstone bridge. Look at the current coming from the battery in this balanced Wheatstone circuit. It enters the bridge at point A and splits into two parts. One part flows towards B, the other flows towards D. If the bridge is balanced, then at points B and D, the current does not split further. Instead, both currents continue forward independently, as if there is no connection at all between B and D. Why does this happen? Because in a balanced condition, the potential at point B is equal to the potential at point D. And when there is no potential difference, there is no current flow between these points. So, the current through the galvanometer becomes zero. Now, what creates this equal potential condition? It depends on the ratio of the resistors. A Wheatstone bridge is balanced when R1 by R2 equals R4 by R3. When this condition is satisfied, the potentials at B and D become equal, and hence, no current flows through the central branch. Now, using this concept, let's come back to the given problem. First, we rearrange the circuit into the familiar Wheatstone bridge form. It is given that the potential at points B and D is the same. This is a very important clue. It directly tells us that there is no current flowing through branch BD, and that is exactly the condition for a balanced Wheatstone bridge. So, we can apply the balance condition. I'll display the relation on the screen. Now, let's substitute the resistor values from the circuit. Again, you can follow them directly on the screen. When we solve this, we are left with only one unknown, which is R. And on solving, we get R equals 20 ohms. So now, the unknown resistance is determined. Now that we have all the resistance values, the circuit looks like this. Also remember, since there is no current flowing through branch BD, we can safely remove it, as it has no effect on the circuit. After simplifying, the circuit becomes much easier to analyze. Now observe. In the top branch, the 10 ohm and 20 ohm resistors are in series. So, they combine into a single equivalent resistance. 10 ohms plus 20 ohms equals 30 ohms. Similarly, in the bottom branch, the 20 ohm and 40 ohm resistors are in series, which again combine into a single equivalent resistance of 60 ohms as shown. So now, the circuit reduces to two resistances in parallel. One branch has 30 ohms, and the other has 60 ohms. Next, we find their parallel equivalent. I'll display that calculation on the screen, and this gives us a net resistance of 20 ohms across the battery. Now, this leaves us with a very simple application of Ohm's law. We can directly calculate the current. I'll show the equation on the screen. Solving this, we get the current as 2 amperes, and that is our final answer. Thanks for watching. If this helped you, share it with your friends. Subscribe for more quick JEE solutions. Got a question? Drop it in the comments. See you in the next video, where we'll solve the problem shown on the screen.